Live from the bottom of the Pacific Ocean, 300 miles off the Oregon coast, high-definition video. Brought to you by APL-UW scientists and engineers.
The camera is at about 1,800 meters, about a mile below the ocean. This is the first time a high-definition camera has been placed on the ocean floor that is capable of delivering the video signal in an uncompressed format. And to go from the standard video output, which is known as HD SDI, out of the camera, and then get that into a format that could be transported over this internet-style 10 gigabit per second fiber optic network was a major challenge, and that kind of hardware didn't exist. We basically have a full-up camera system that we can manipulate with various parameters. Pretty much everything that you could imagine that you could do with a handheld camera, we can do from the seafloor.
HD video is just the beginning of a new undersea network of eyes and ears. APL and the UW School of Oceanography are spearheading a $239 million National Science Foundation project to wire a big chunk of the seafloor of Oregon and Washington with broadband internet and high-voltage power. By 2015, the goal is to provide live, real-time, 24/7 data flows from the deep sea floor. A wide array of instruments will constantly monitor currents, temperatures, salinity, life forms, and volcanic activity.
So in the coming dive, we're going to be using the Ropos ROV to go down, lay a cable, and be able to connect instruments at both ends.
A crucial first step in creating the regional scale nodes network, lay miles of fiber optic cables that form the backbone of the network.
We had some really interesting terrain on the seafloor to deal with, all kinds of lava flows, some big collapsed areas, and so figuring out how to lay the cable in a way that we would start it and end each cable in the locations that we needed to make our measurements was a challenge. We were successful at getting 23 kilometers of cable on the seafloor.
I was the person responsible for designing most of the electronics in the junction boxes that we put down that interfaced with the instruments.
In short order, a newly installed seismometer detects an event.
I think within about 15 minutes or half an hour at least of turning on the seismometers, we actually saw our first earthquake. That was quite the experience to be involved and see that.
The installation of the instruments is, is painstaking because all of these are seismic instruments that have to be leveled into place, and to turn it on and have all systems work flawlessly and to get that data, pretty exhilarating, and to see that there really is, it's a very active location, and to see the science coming alive right in front of us was pretty impressive.
Ready to go back to sea to continue work in 2014?
We got a lot of work before we're ready to go back next summer, but sure, absolutely.
Yeah, looking forward to it.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.